Physical significance of divergence of a vector divergence operates on a vector to produce a scalar. So it is a transition from a vector field to a scalar field. One thing should be noted that these are meaningless. Next significance: divergence of a vector, let us call the vector f, at a point, let us call the point P, is a measure of how much the vector f spreads out that is diverges from the point P, or converges to the point P. In a nutshell, divergence is a measure of amount of spreading of vector from a point. Divergence is amount of spreading. This is the key word. Third significance: concept of divergence leads to the definition of source, sink, and solenoidal fields. If divergence f is greater than 0, then vector f is called source field. We say that the field is divergent the field lines scatter or spread out. If this is a point P, which is a source field, the field lines are divergent, means the field lines will appear to emanate from or emerge from this point P. And if we enclose P by a surface, closed surface, then as we move on the surface, we will always find the field lines to be coming out, implying that P is a source. So field lines are spread out from the point P. They are divergent from the point P. We will say that there is a net outward flux. And the word flux comes right from the definition of divergence. Divergence is flux per unit volume as the volume shrinks to zero. Divergence is a measure of the outward flux. In this case, there is a net outward flux and therefore divergence is positive and hence this point is source. So let us write, in this situation there is a net outward flux because field lines are only coming out, none is going towards P. Also we note that field lines are straight lines. If divergence of vector f is less than 0, that is negative, then vector f is called sinc field. Field is convergent. Field lines coalesce or merge, they concentrate. Towards a point. So if P is a point and the field lines are directed towards P from all ends or from all sides, from all directions as shown here, then P is definitely a sinc point. And if we consider a closed surface of any shape enclosing this point P, and if we move on the closed surface, we will find that lines of force are only entering into this region and they are directed towards P. In other words, there is a net inward flux. So there is a net inward flux and field lines are straight lines. Here field lines only enter and in this case field lines only exit, and this is a closed surface. Here too, this is a closed surface. We shall give physical example of these situations. It is to be noted that the definition of divergence involves flux, which is called outward flux. But if divergence F is negative, as in this case, this means the end cap is pointed inward, and therefore it is clear that negative divergence implies inward flux, while positive divergence involves outward flux. If divergence vector F is 0, then vector F is neither a source nor a sink, and we call vector F to be solenoidal. This means neither divergent nor convergent. It follows straight away from the definition of divergence F that if divergence F is 0, then the flux is also 0. So net flux is 0. And this is possible if number of field lines making entry into a closed surface and making exit are equal. So equal amount of divergence and an equal amount of convergence will make the field at that point solenoidal. Let us consider a swarm of birds that are flying in this manner up above in the sky. So these arrows indicate the flying birds, and the birds are following one another. It is clear from this diagram that the source is on this side because they are coming from the left side, and the sink is on this side because they are moving towards that point. So this is source and this is sink. And let us consider a closed surface in this region. If we move over the closed surface, we find that there are entries of field lines into the closed surface and there are exits also. If we now count the number of entries, it will be equal to the number of exits, which means nothing is stored in this region of space. So this is a solenoidal field, neither a source nor a sink. The birds just fly past. They enter into this region, do not stay here, and just move away. And none of them are created here. And so if there are n birds entering, there will be n birds making their exit, showing the solenoidal nature of this region. Next, application of divergence in physics. Consider a positive charge, say plus Q, which is located at this point. Let us draw the field lines. It is clear from the lines of electrostatic field due to this positive charge that this is a source of electrostatic field, because if we enclose it by a surface, lines of force only move out across the surface. So there is a divergence of field lines, there is a net outward flux, and divergence E is positive. Let us consider a negative charge, a point charge. So this is the negative point charge, and the field lines will be so the electrostatic field lines are convergent to this point. So this is a sink point in contrast to this point, which is a source point. And in this case, divergence E will be negative, If we consider a surface, a closed surface enclosing this point, then across the surface lines of force will only go inside. So there is a net inward flux, and hence field is convergent. Divergence is negative. The value of divergence E is given by Maxwell's first equation of electrodynamics. And it is equal to rho by epsilon 0, where rho is charge density. And in this case, we have a positive charge, so rho is positive. In this case, rho is negative because we have a negative charge. So this is a case of source and this is a case of sink. And the definition of divergence contains the outward flux, the value of which is given by where AC is this closed surface, and this is the famous Gauss Law of Electrostatics. Where epsilon 0 is the permittivity of free space and Q enclosed is the charge enclosed by S. And obviously, for this case, since Q is positive, this is also positive, and for this case, since Q is negative, it is negative. So this is the flux which is related to the divergence. Let us come to the third example. Consider a magnetic dipole. This is the north pole and this is the south pole, and let us draw the lines of force. These lines of force emit from the north pole and they bend and move around and then fall upon the south pole and then continue from south to north within the magnetic dipole, within the magnet. The lines which we have drawn are B lines, or the lines of magnetic induction. Let us enclose this magnet or a magnetic dipole by a closed surface. So this is the closed surface which we have considered, and let us move over the closed surface to investigate how many lines have entered the surface and how many exits are there. We find that so far as this very diagram is concerned, the number of entrances are 1, 2, 3, 4, 5. and the number of exits are 1, 2, 3, 4, 5. So there are 5 entries and 5 exits. So the net flux is 0. And from the definition of divergence of B, it follows that the flux is 0. So since number of entries and exits are equal, the net flux is 0. In other words, there is no net divergence, no net convergence. So the B field will be a solenoidal field. So divergence B will be 0. And from the definition of divergence, it clearly follows that the flux of vector B over a closed surface S will be 0, which is Gauss law of magnetostatics, and this is Maxwell's second equation of electrodynamics. This is Gauss law of magnetostatics. Here we should be cautious about one thing, that the surface should be closed. The flux of B over an open surface may not be 0, but over a closed surface it is 0, which is Gauss law of magnetostatics. The B field is solenoidal, neither source nor sink, since divergence B is 0. Let us note that the lines of B are closed lines, in contrast to the lines of E, which are open lines. The E lines start from the source and go to infinity, and here the E lines come from infinity and fall on the sink. So E lines are open lines, but B lines are closed lines. They bend and close upon themselves. The B line emerges out from the North Pole but is attracted by the South Pole, and so there is bending, and finally it enters into the South Pole. Within the magnet, the line continues from south to north, so it is a closed line. An important point follows from this discussion, that we cannot isolate a North Pole. Whenever the B lines emit from the North Pole, it bends and it searches for the South Pole. So North Pole cannot stay isolated. The same is true for the South Pole also. So divergence B equal to 0 indicates non-existence of isolated North Pole or isolated South Pole. This result, that divergence B is 0, indicates non-existence of isolated magnetic poles, that is North Pole or South Pole, in other words magnetic monopole. And also the fact that North Pole and South Pole cannot be separated, are inseparable. Let us give another example. Let us consider a mass point, and the region surrounding a mass is a region of gravitational field. Now, if E is the gravitational field, then the E lines are of this type, because gravitational field is always attractive. If we bring another mass in this field, there will be attraction. So clearly, this point mass is a sink point. It is a sink field, and divergence of E is negative. If we enclose this mass by a closed surface, say S, then the outward flux will be negative, meaning that it is actually an inward flux. The gravitational field lines go into this surface, penetrate into the surface. So E lines are convergent. Sink point, sink of the gravitational field E. Here E represents the gravitational field due to M, this mass. Now the value of divergence E is given by a famous law, which is Gauss theorem on gravitation. In differential form, according to which where rho is mass density, and G is the universal constant of gravitation. And the value of the flux of vector E over this closed surface, as present in its definition here, is given by where M enclosed is the mass enclosed by the surface S, and this law is called Gauss theorem on gravitation in integral form. Note that this is always negative. But Gauss law of electrostatics can have a positive right hand side or a negative right hand side. This is Gauss law of electrostatics. Compare the right hand sides. Right hand side of Gauss theorem on gravitation is negative because mass is only of one type. Mass is attractive. Two masses cannot repel. On the other hand, the right hand side of Gauss law of electrostatics can be positive as well as negative because charges are of two types, positive and negative, and charges can attract as well as repel. Consider another application of divergence. Let us consider a region where there is flow of fluid and liquid particles are flowing in streamlines, one following the other. Each particle follows the one which moved before it into the tube. So this is how the particles are streaming or moving from left to right. It is clear from this diagram that this is the source and they are moving towards a point which we may think that it is a sink, and this is the flow tube, and these arrows represent velocities. So arrows are velocities of liquid particles. What will be the value of divergence of vector v? If we consider a closed surface, then we find that number of entrances and number of exits are same, which means there is no net flux across this closed surface. Yes, this means as the flux is zero, the divergence is also zero. So V is solenoidal. We also note that there is no scattering, there is no spreading. In other words, there is no divergence or there is no convergence. V is the velocity field. We note that there is no scattering or spreading. In other words, there is no divergence. Flow is not like this, that it is spreading outwards. And there is no convergence either. That is, the flow is not like this. That the field lines are proceeding towards a particular point. In other words, there is no storage of liquid here, and also there is no depletion of liquid here. So this is a region which is neither a source nor a sink, and hence solenoidal. So these are important points. So there is no storage and there is no depletion also.